Now, let me get into the ordering principle. So, how are we going to compare ordering of interval value fuzzy number? What we are given with? We are given with two fuzzy numbers, interval value fuzzy number. So, interval value fuzzy number is nothing but what? It's nothing but a closed interval. You understand it in a simple words in this way. So, we are given with two closed intervals. Let us take closed interval 0.3, 0.4. Another closed interval 0.1, 0.2. Right? One closed interval, we name it as capital A, 0.3, 0.4. Capital B is nothing but closed interval 0.1, 0.1. How are we going to say whether A is greater than B or B is greater than A? So by means of one function, we are going to do that. What we are going to do here, this is also a closed interval, this is also a closed interval. We cannot compare each and every element of closed interval. If we are trying to compare, we need to consider infinite number of values. So what we are going to do, we are going to apply some function f on capital A and f on capital B as well. So f on closed interval 0.3, 0.4. So that f of A value is nothing but what? If my closed interval A, B, S is nothing but A plus B by 2. For example, for the closed interval 3, 4, 0.3, 0.4. What would be your S of A value? It's 0.3 plus 0.4 by 2. It's 0.35. What about your B, capital B? It was 0.1, 0.2. So S of B is nothing but what? 0.1 plus 0.2 by 2, it's 0.15. So the previous case it was 0.35, the second case it is 0.15. So which is greater? 0.25 is greater, right? So A is greater than B. So this is how we are comparing two interval value fuzzy number. What we are going to do for an interval value fuzzy number, we are going to apply a function S. S of A and S of B we are going to calculate. What does it return? It returns a real number. Any two real numbers are compared by means of less than relation. So S of A is greater than S of B. So by using S of A value, I am going to say A is greater than B. So this is what the meaning of ranking A and B by using score function S. Now the problem is nothing but what? Whether the score function effectively differentiate two closed intervals. For example, now let me consider another closed interval. One closed interval is 0.3, 0.4, right? You please remember 0.3, 0.4, closed interval 0.3, 0.4. Another closed interval I am giving closed interval 0.2, 0.5, right? What can you talk about? Capital A is closed interval 0.3, 0.4. Capital B is closed interval 0.2, 0.5. What can you say about its S of A and S of B? S of A is nothing but what? 0.3 plus 0.4 by 2, it's 0.35. S of B, it is 0.2 plus 0.5 by 2. It is again 0.35. So S of A equal to S of B. What should be written? Then A equal to B. This is what we are supposed to written, right? But it is so clear that the closed interval 0.3, 0.4, it is different from the closed interval 0.2, 0.4. So this score function, by use of this score function, we cannot discriminate such kind of interval. That is the reason why we are going for another score function. We are defining it in this way, B minus A by 2. Now for the same interval, whatever which are ranked equally, you consider it. 0.3, 0.4, it is nothing but what? 0.3 minus 0.4 is nothing but minus 0.1 by 2, it's minus 0.05. What about 0.2 minus 0.5 by 2? It would be minus 0.15. So minus 0.05 is greater than minus 0.15. So again, we can say that the first interval is greater than the second. So this is how we can differentiate any two interval numbers. So what is the ranking principle basically? We are going to apply the first function S. If it fails to rank, then we will be using the second function. If it ranks, then we will stop. If it fails to rank, then we will apply our second function. So we are applying the function one by one. Whether the first function ranks, we are done. We can stop the procedure. If the first function fails, we will go to second function. So this is how a ranking principle works. Now, why did we discuss about the ordering of interval value fuzzy number? Because we wanted to define ordering on the trapezoidal fuzzy number. So what we are going to given with? We are going to be given with two trapezoidal fuzzy numbers. Again, trapezoidal fuzzy numbers are represented by means of a four tuple A, B, C, D, which is nothing but what? Which is nothing but this geometric figure. This geometric figure is represented by means of 4 tuple ABCD. Don't misunderstand the concept of this ABCD to be an element of R4. No, it's not an element of R4. It is nothing but this function is represented by means of this. So how can we find out its membership function for this trapezoidal fuzzy number? It is so simple by means of geometry. So what is the line joining? So see, we wanted to write out a membership function for this. So what is the line joining these 2 points a comma 0 and b comma 1? It is nothing but y minus y1 by y2 minus y1, which is equal to x minus x1 by x2 minus x1. By using which you can find out its membership value, membership function in this way. And between the interval b to c, what is its membership value, which is exactly equal to 1. Similarly, between c to d, the membership value is nothing but line joining these 2 points, c comma 1 and d comma 0. That is how we have obtained the membership function for the trapezoidal fuzzy number a equal to ABCD. And in all other place, the membership value is basically what? The membership value is 0 in all other places, which are less than a as well as greater than b. Now, if you are given with 2 trapezoidal fuzzy numbers, how are we going to compare? Again, there are different ways of approaching this ranking principle. Now we are going to compare by means of one value. What we are going to do basically, we are going to use the idea of alpha cut to compare to trapezoidal fuzzy number. What is the meaning of it? A is a trapezoidal fuzzy number for a specific value of alpha. Instead of this alpha, let us say if it is a 0.6. So it is basically where from 0 to 1, let us consider 0.6. So 0.6 cut gives you this closed interval, right? So I wanted to compare two trapezoidal fuzzy number. So what am I going to do? I'm going to consider their alpha cut for a specific value of alpha. I'm going to consider 0.6 cut for capital A. Similarly, 0.6 cut for capital B. Now, what can you talk about 0.6 cut of capital A? It is nothing but this closed interval. Similarly, for capital B, there would be another closed interval. Just now we have discussed how to compare any two closed intervals by means of this ranking principle, right? So what am I going to do? I'm going to give a specific value of alpha. With respect to that specific value of alpha, A and B are two trapezoidal fuzzy number, give a closed interval. Now, the problem is nothing but what? Comparing two closed interval. How am I going to compare these two closed interval? By means of this ranking principle, right? So this is the basic idea. So here, for any trapezoidal fuzzy number, this is the formula. How can you calculate it? It's simply by solving the equation. Simply by solving the equation y equal to alpha, x minus a by b minus a, which is equal to alpha. If you solve this, what would be your x? It would be a plus b minus a times of alpha. This is nothing but this. Similarly for the other value, right? So hope you can understand. Even if you are not able to understand this, you please contact me. I'm ready to answer you. Now, what are we going to do that? This is what the basic idea. See, you consider this triangular fuzzy number. Now, this is nothing but the decomposition theorem. What is the idea of decomposition theorem? What am I going to do? I'm going to define a total ordering principle by using alpha cuts and by using the idea of decomposition theorem. So, what is the idea of decomposition theorem? Let us consider this triangular fuzzy number, this triangular shape. We wanted to identify this triangular shape. How are we going to identify this triangular shape? We are going to see, just imagine this. Imagine in this way. This is nothing but a chalk piece box. Chalk piece box. This is nothing but what? This line segment you consider as a chalk piece of this particular length. Similarly, this entire box can be filled by means of chalk pieces. Do you agree with me? Do you agree with me? So the idea is nothing but what? You fill the box by means of chalk pieces. What am I going to do? Without any gap, if you fill the chalk pieces, what is the meaning of it? You are covering this entire region, right? Guys, is this clear? If you are considering for all alpha value, so how am I going to identify this triangular shape? I'm going to identify by means of these line segments. Means of these line segments. What are these line segments? These line segments are, roughly I'm saying, these line segments are nothing but coming from alpha cuts basically. So this fuzzy set, what is the nature of this fuzzy set? It is imprecise in nature, but which can be identified by means of the line segments. What is the nature of these line segments? These are alpha cuts which are crisp set. So this is what the idea of the decomposition theorem. This entire triangular shape is decomposed by means of these small line segments. And these line segments are obtained by taking the values between 0 and 1. How many values are there? Infinite number of values are there. So how many chalk pieces can be accommodated within this box? Infinite number of chalk pieces. Now the problem is nothing but what? If I'm planning to compare two triangular fuzzy number, for this particular alpha value, this is my closed interval. For another number, another closed interval will be there. By means of it, I'm comparing, right? But a fuzzy number is identified by means of how many number of parameters? Infinite number of parameters. If we are able to achieve certain tasks by means of infinite number of parameters, we are inferior, right? So at least we must be able to identify something by means of finite number of parameters. What is the meaning of it? Originally, the idea of decomposition theorem is taking a value between the entire closed interval 0, 1. How many values are possible? Infinite number of values are possible. What we are trying to do, can we replace this infinite number of values with some finite number of values? This is what our aim. This is where the question arises and people have tried to solve it. Which means what? We wanted to identify the fuzzy number by means of finite number of parameters. See, what is the basic idea of decomposition theorem? The left hand side is basically the fuzzy set, which is imprecise in nature. The right hand side is basically the special phase set, which are made up of alpha cuts, which are precise in nature. We wanted to identify imprecise things by means of precise things. So this is what the basic idea of any decomposition theorem. Here alpha can take value in the entire closed interval 0, 1, which means that alpha, the fuzzy set A is identified by means of infinite number of parameters. Now we wanted to identify this fuzzy set by means of finite number of parameters. For that we are going to use the idea of upper down sequence. So what is the meaning of upper down sequence? So first of all, what is the basic idea of using this? Instead of considering all the values between 0 to 1, I'm going to consider some sequence of numbers in this closed interval 0, 1. Which means what? I'm not going to consider the infinite number of values. I'm going to consider only the finite number of values. But what kind of sequence I should consider? I'm considering it to be upper dense. In a simple words, how can I make you understand the idea of upper dense? It is nothing but what? A set is said to be upper dense in closed interval, the closed 0, open. For every small x in this closed interval 0, 1, and for any epsilon value, we must be able to find out the delta in D such that which lies in the right epsilon neighborhood of x. Right epsilon neighborhood of x. Then we call such D as upper density. Let me repeat. For any x in closed 0, open and 1, and for any epsilon, this is what you are given with. We must be able to find out delta in D. D is nothing but what? Subset of closed interval 0, 1. We must be able to find delta for each epsilon. And the delta should lie in the right epsilon neighborhood of a point x. Then we will call it as upper dense. Similarly, once we are able to talk in the right epsilon neighborhood, if we expect our delta to be in the left epsilon neighborhood, we call it as lower dense. And dense, it is nothing but what? Lower continuous, upper continuous, continuous from right, continuous from the left. What is the meaning of continuous? It should be from both. So similarly, set is said to be dense if it is in the either in the left epsilon neighborhood or in the right epsilon neighborhood. So this is what the meaning of dense. So this is what is the meaning of it? How does it improve the scenario basically? Here is an example of one